practice identifying stereocenters in organic molecules. So first off, what is a stereocenter? A stereocenter is a carbon bonded to 4 unique groups. So we'll say 4 different groups. So going through, I'm going to circle what may be our primary stereocenter in each molecule. So we have the central atom of focus, and we're trying to figure out if these are stereocenters. So let's go through, starting with the top left example. So let's count the unique groups on each central atom. So in the top left, this carbon is bonded to a bromine, a chlorine, an ethyl group, and a methyl group. So since we have 4 unique groups bonded to the central atom, we can say that yes, this is a stereocenter, so we'll highlight that in green. Next, we'll go to our second example, which looks pretty similar. We just have one different group than our first example. So let's count again. We have a bromine, a chlorine, a methyl group, but then we have another methyl group. So are these unique from each other? No, they are not. So this only has 3 unique groups. So this is not a stereocenter. Our third example, at first glance, looks like it just has 3 substituents, but we need to remember here we have a hydrogen bonded to the central carbon. So if we go around and count our different groups, we have this methyl group, bromine, hydrogen, and chlorine. So this example does have a stereocenter on the central atom. Going down to the bottom row, we have 2 examples that look fairly similar. So let's start on the left and count our different groups. So we have a bromine and a chlorine, but let's go and see if this cyclic compound bonded to the carbon constitutes 2 unique groups. So if we go through, starting at the central atom, if we go, we have a carbon with 2 hydrogens bonded. If we continue up, we have another carbon with 2 hydrogens, carbon with 2 hydrogens, carbon with 2 hydrogens, and then we're back to where we started. But if we go around in the opposite direction, we have carbon with 2 hydrogens, carbon with 2 hydrogens, carbon with 2 hydrogens, carbon with 2 hydrogens, back to center. So these groups are identical. So this is just one unique group. So this is not a stereocenter. But if we look at our next example, we notice that it has this substituent, which I'll highlight in yellow. It has this methyl group bonded to the cyclic compound. So does that change things for us? Let's go around and see if it does. So we have the bromine and the chlorine. And then let's take a look at our cyclic compound. So we have carbon with 2 hydrogens, carbon with 2 hydrogens, a carbon with 1 hydrogen and a methyl group, carbon with 2 hydrogens, and back to our central atom. Going in the opposite direction, we have carbon with 2 hydrogens, and then the second carbon we get to is the carbon with a hydrogen and a methyl. The third atom is a carbon with 2 hydrogens. The fourth is a carbon with 2 hydrogens, and then we're back to the central atom. So here we do have 2 unique groups because going in one direction, we have the second atom has the methyl, but going in the first direction, the third has the methyl. So this is 4 unique groups. So yes, this carbon is a stereocenter. Moving on to our last example, we see this skeletal model of an organic molecule, but let's see if it has 4 unique groups bonded to the central carbon. So here, let's remind ourselves that we have a hydrogen bonded. So we have an ethyl group, a methyl group, a propyl group, and the hydrogen is the fourth unique group. So this example is a stereocenter.